Okay, today we are taking those parent functions from yesterday and doing some transformations with them. The only two transformations we are concerned about today would be what's called a phase shift, which is movement left to right, and a vertical shift, which would be movement up or down. Now, looking at this equation in the top left of your handout, this is the generic formula. Now, this one does have sign, but this works if you replace it with cosine, or if you had tangent, secant, cosecant, and cotangent. So these transformations are true for all 6 of these parent functions we saw yesterday. And we have values of A, B, C, and D. So there are 4 types of transformations. We're only doing 2 of them today. We're doing the phase shift and the vertical shift. And over here to the side, it tells you what each of those values do to the parent function. So the A value affects the amplitude. Now the amplitude is the measurement from the middle of the graph to the maximum of the graph. And let me sketch in the sine parent function. So amplitude is the distance from the middle of the graph to the maximum. So for that sine function, what is the distance from the middle of the graph to the top? How many units is it? 1. So for the sine function, the amplitude is 1. Now the amplitude can also be measured from the middle of the graph down there to the minimum. And that is also 1 unit. So it doesn't matter if you measure from middle to the maximum or middle to the minimum. It's going to be the same for sine and cosine. So the A value affects the amplitude, and we'll be doing those transformations tomorrow, so don't worry about the A value. The B value affects the period. It will either make the period longer or shorter. The C value is a phase shift, and if you want to make a note, a phase shift means it translates your graph left or right. So the C value, the number inside the grouping symbol, translates your graph left to right. And let me just write down an absolute value function. This was vertex form for the absolute value parent function. And inside my grouping symbol, what does the H stand for? Horizontal. So the value inside the grouping symbol, that C value, will make it move left or right. So if it's a negative, it moves it to the right. If it's a positive, it moves it to the left. So it's similar transformations to what we've seen before. Now the D value, the number that's added or subtracted to the back, just like over here, what does that K value do to that absolute value parent function? Moves it vertically up or down. So the vertical shift, that D value will make it move up or down. So the number inside the grouping symbol moves it left or right. The number behind the grouping symbol moves it up or down. Okay, now we are going to see some of those translations on our graph. So we're going to use an 83 or 84 student choice. And the instructions say to graph the following trig functions on your graphing calculator. So the first thing I want you to do is go ahead and clear the memory. So second, plus sign, 7, 1, 2. So clear the memory. And in Y1, we're going to type in sine of x. And we'll just do that to begin with before we type in the other 2 functions. So let me show you on the Elmo what I'm doing. And if you can't see what's on the Elmo, then you will just have to listen to the steps. But you all are here, so you do not have to worry about that. Okay, so the first thing I told you to do was to clear the memory. The next thing you need to do is go to y equals. So hit that top left button for y equals. And in y1, we're going to type in that top equation, which is sine of x. And the sine button is 2 above the number 7. X, if you remember, is right beside that green alpha key. So hit X, and then close the parenthesis. So in Y1, we're going to type in the sine of X. Now we're going to look at the graph so we can remember what does the sine parent function look like. So hit the graph button, top right button. Now there's my sine parent function. Now notice the default settings are -10 for the x-axis to +10 and -10 to +10. I want to change these window settings. And if you remember from yesterday, what did our x-axis go from? The +2 pi was over here. What was over here? -2 pi. So when I'm going to change my window, you'll hit that second button, top left, second one, hit that window button. And we need to change the x-min and the x-maximum. So our x-min, we're going to change this to -2 pi. And for the pi symbol, you do second and then this caret key, which is right above the division symbol. So second and then this caret key right here. Now, on my screen, it shows -2 pi. But what happens when you hit enter? What did you get? A decimal, because what your calculator is doing the math. Because what is pi approximately? 3.14. So what's -2 times 3.14? -6.28. So that's where that number is coming from. Your calculator just did -2 times pi. Now for x maximum, I'm going to change this to +2 pi. So x max, we're changing to +2 pi. Now x scale, I'm going to leave that at 1. For the y min, I'm going to change that from -10, change that one to -5. And y maximum, change that to +5. So y min and y max are -5 and +5. Now if I hit the graph button, now it made it to where I can see the parent function a little bit more clearly. Okay, so now we're going to go back to y equals, so top left button. Now arrow down, and in y2, we're going to type in that second equation, which is sine of x. So sine x, close the parenthesis. And behind the parenthesis, we need to have a -2. Now, what is that number at the back of the equation going to make our graph do? Go down how many? 2 units. So let's watch and see. So when I hit the graph button, y1 will be graph first. So the parent function will be graph first. And here comes the second one. So there's y equals sine of x -2. So we see that the -2 made every point translate down 2 units. Now I'm going to go back to y equals, and now instead of the -2, I'm going to change that to a +2. So if the -2 makes it move down 2 units, what would the +2 at the back make that function do? Move up 2 units. So let's see if that's true. So here's the parent function, and there's y equals sine of x +2. So the +2 at the back made it translate up 2 units. Do you need help with the calculator? Okay, so now we need to go back to the handout and it asks us what effect does the number behind the trig function have on the graph, and the -2 and the +2, what do they do to our parent function? Up and down, so it translates the graph up or down. So if it's a positive, it moves it up. If it's a negative, it moves it down. And those are the same transformations we are familiar with. Okay, so now we are going to do that to some of these parent functions from yesterday. So now we're going to translate those graphs up and down. Okay, so problem number 1, we have y equals sine of x +3. Now over here to the side, I'm going to sketch a graph of what the parent function looks like. So for the sine parent function, it starts at 0, it ends at 0, halfway it's at 0, a fourth of the way it's at positive 1, 3/4 of the way it's at negative 1. So this is just a basic sketch of what the parent function looks like for sine.
Yes, can we get homework?
Okay, so looking at problem number 1, we have y equals sine of x plus 3. And I just graphed the parent function. Now looking at that equation, what will that plus 3 at the back of that trig function do to our parent function? What does this plus 3 make the graph do? Up 3 units. So if I start over here at the origin, instead of being at the origin, I need to translate that point up 3 units. So where do I need to start? 0, 3. So it starts at 3, it ends at 3, halfway is also at 3. So those 3 values are at the same horizontal. Now, a fourth of the way, what is this y value right here?
1.
1. So instead of being at 1, if I move that up 3, where would that point be? 4. So pi over 2 should be at positive 4. And 3 pi over 2 should be where? Yeah, this right here, what's the y value down here? Negative 1, so if I add 3 to that, that would be at 2. And we have made one series. Make sure this is curved. Don't make it pointed. Make sure it is rounded. So at pi over 2, make sure it's curved. At 3 pi over 2, make sure it's curved. It needs to be rounded. Now I need to complete one more cycle. So over here at negative 2 pi, it starts at 3, it ends at 3, halfway it's also at 3. At negative 3 pi over 2, it bumps up 1 unit, and at negative pi over 2, it bumps down 1 unit. Now on your assignment, they might ask you for the phase shift. So a phase shift means movement left or right. Did this graph move left or right? No. So on your assignment, you would write none. If they ask you for a vertical shift, this one did move vertically which way? Up 3 units. And it may ask you for the amplitude. Now the amplitude is the distance from the middle of the graph, and the middle of the graph is right here at 3, to the maximum. So from the middle of the graph to the maximum, what is this distance right here? 1. So the amplitude is 1 unit. And they may ask you for the last one might be the period. So how many units does it take to complete one period? 2 pi. So today the periods are not changing. We'll change the periods tomorrow. So that's how you would answer those questions on your assignment. So if there's not a phase shift, you would write no. Next one, number 2. Number 2, we have the cotangent parent function. And what is this minus 3 at the back going to make that function do? Go down 3 units. And over here to the side, I'm going to sketch what that cotangent parent function looks like. The cotangent parent function has a vertical asymptote on the y-axis. And it has another vertical asymptote at pi. The middle point is on the x-axis, and the left arm points up, and the right arm points down. Now I will mention that when you are drawing the cotangent or tangent parent function, you have to have all three of those points. So any tangent function you draw, it has to have 3 points. Any cotangent function that you draw, that has to have 3 points. Okay, now we need to move all three of those points down 3 units. But the first thing I need to take care of would be those asymptotes. So the only direction those asymptotes could move would be left to right. But does this graph translate left to right? No. So the vertical asymptotes will stay where they are. So the first one is at 0, and the second one is at pi. Now the middle point is normally right here at the x-axis. But when I move that point down 3 units, where would it be? Down here at -3. So pi over 2, drop it down to -3. Then the left arm points up, so go up 1 unit, and the right arm points down, so on the right side, go down 1 unit. Now that is only one period. Do I leave my graph with only one period on here? No, you need to fill up the entire graph. So where would the other asymptotes be?
2 pi.
2 pi. Where else? -2 pi. And where else? -pi. And make sure all of these have 3 points. So that middle point needs to be at -3, -3, -3. For cotangent, left arm is up, right arm is down. Left arm is up, right arm is down. Left arm is up, right arm is down. And make sure when you are drawing in your cubic function that you go all the way from the top of your grid to the bottom of your grid. Now we'll answer these orally. If they ask you for the phase shift, that means movement left or right. Did this graph move left or right? No, so you would put none. For vertical shift, which way did it shift vertically? Down 3 units. And for the period, what is the period length for cotangent? Pi. So pi units. Okay, next section. Now we need to see what happens when we change the p-value. So the instructions say to graph the following trig functions on your graphing calculator. So we already have the parent function still in y1. Now in y2, we are going to change it. So change in y2 to the equation that we have. Now notice we have this pi over 2. Is that degrees or radians? Radians. If it has the pi symbol, that's in radian measure. Well, we already cleared the calculator's memory, which put our calculator in radian mode. So we're good to go. So let me show you what that would look like on your calculator. So we have sine of x in y1, and in y2, we have sine of x, and inside the parentheses, we need to have pi minus 2 subtracted from that x. So inside the parentheses, you need to have x minus pi divided by 2. So x minus pi divided by 2. Now, this value is inside the grouping symbol. So if the number is inside the grouping symbol, what type of translation do we have? Horizontal. It's going to move either left or right. So if it's a minus, which way does it move? To the right. So let's hit the graph button and see. So here is the parent function. So looking at the origin, did this point move to the right, pi over 2 units? Did the starting point move to the right, pi over 2 units? Yes, it did. Now we're going to do one more change, go back to y equals, and instead of the minus pi over 2, let me change that to a plus pi over 2. So if a minus moves it to the right, what will a plus do? Move to the left. So here's the parent function. Did that starting place at the origin move to the left pi over 2 units? Yes, it did. So the number inside the grouping symbol will move our graph left or right. Yeah, cosine is just a horizontal translation of the sine function, or vice versa. Okay, so what happens to the graph? Translate left or right. Same thing for the phase shift. The phase shift takes your function and translates it left or right. So both of those questions have essentially the same answer. So if the value that's being added or subtracted is inside the grouping symbol, it moves that function left or right. We ready? Okay, number 3. Number 3, what's the parent function? Cosine. So the cosine parent function, let me sketch a graph over here. Cosine parent function starts at 1, it ends at 1, halfway it's at -1, a fourth of the way it's on the x-axis, 3/4 of the way it's on the x-axis as well. Okay, so there's the cosine function. Okay, so notice we are adding or subtracting inside the grouping symbol. So if you're adding or subtracting inside the grouping symbol, that is a horizontal translation. So if it's a plus pi over 4, which direction does it move?
Okay.
Left pi over 4. So if it's inside the grouping symbol, it moves it left or right. And it's the opposite of what you would think. So if it's positive, you would normally think it's to the right, but it's to the left. So all of those points need to be shifted or translated left pi over 4 units. So instead of starting at 0, 1, that initial point needs to be translated to the left pi over 4 units. And we talked about the x-axis yesterday. If this is pi over 2, half of that would be pi over 4. So it's actually scaled by pi over 4 increments. So if I need to move to the left pi over 4, then I just need to move 1 unit to the left, which would be pi over 4 units. So that first point is at negative pi over 4, 1. And let me just put in some values. So right here, halfway, or actually, what is the entire cycle or period length for cosine? 2 pi. So halfway would be pi. And this value right here, what's the x value here? This is halfway to pi, so that would be
pi over 4.
Pi over
2.
2, and over here would be 3 pi over 2. So for pi over 2, that is normally on the x-axis. But if I move it to the left pi over 4 units, where would it be? Right here, pi over 4, 0. Instead of being at pi over 2, 0, it moves to the left, pi over 4 units. So it's at pi over 4, 0. And this point down here is normally at pi, but if I move it to the left, pi over 4 units, where would that be? 3 pi over 4, and that y value at the bottom is -1. And at 3 pi over 2, it's normally on the x-axis. So this point, move it to the left, pi over 4 units, and where would that point need to fall? 5 pi over 4 is on the x-axis. And that last point, 2 pi, if I move it to the left, instead of 2 pi, where would it be?
5 pi over 4.
We just did 5 pi over 4, so this one would be 7 pi over 4, because 2 pi is equal to 8 pi over 4, so that one would have to be 7 pi over 4. Okay, so we made it, but we did get one complete period of cosine. And we need to finish this cycle. Okay, so we have this part that is concave down. We need to finish this part that is concave down. So we need to have our next point at -3 pi over 4. Will be on the x-axis. -5 pi over 4 would be at -1. And -7 pi over 4 would be back to the x-axis. Now this one did have a phase shift. What was the phase shift here? It moved left pi over 4 units. What about for the vertical shift? None. And for the amplitude, what's the amplitude here? 1. And the period, what's the period for cosine? 2 pi. Next example. Now we have the tangent function, and inside the parentheses we have x minus pi over 4. So if you're adding or subtracting inside the grouping symbol, that will move its function left or right. So if it's a negative, which direction will it move? Right, pi over 4 units. Let me sketch what the parent function looks like. So for tangent, we have 2 vertical asymptotes. This one is at -pi over 2. This one is at +pi over 2. Central point is at the origin. And for the tangent, it's the left arm that is down. Now, since this graph does move to the right, pi over 4 units, we do have to move those vertical asymptotes. So normally, this one that's on the left side is normally at -pi over 2. So it would normally be right here. But if I move it to the right pi over 4, where would it need to go?
3 pi over 4.
We're moving it to the right pi over 4 units, so it would be at -pi over 4. Or if you just want to add pi over 4 to this is -2 pi over 4 plus pi over 4 gives me -pi over 4. And you can do the same thing here. If you add pi over 4, that would be 2 pi over 4 plus 1 pi over 4. So that next vertical asymptote should be at 3 pi over 4. Now, does this graph move up or down? No. So that central point, so find the center in between those 2 asymptotes, and that central point needs to fall on the x-axis. The left arm is down, and the right arm is up. And again, when you're graphing tangent or cotangent, you have to have all 3 of those points. And make sure your cubic function goes from the top of the graph to the bottom of the graph. and make all the cycles that will fit, including partial cycles. And where would the next vertical asymptote fall? 7 pi over 4. Where would the last vertical asymptote fall for this grid? Negative 5 pi over 4 is correct. Okay, central point is on the x-axis. So put your central point on the x-axis. The left arm is down, right arm is up. Left arm is down, right arm is up. And include your partial cycle. And when you draw in your cubic functions, make sure you go all the way from the top of your graph to the bottom of your graph, except for like a little partial one like that one. So fill up the entire grid, from negative 2 pi to positive 2 pi. For the last two problems, 5 and 6, now we're putting it all together. Now we're doing phase shifts as well as vertical shifts. And now I'll have to do both in one graph. So let's look at number 5. Number 5, here the parent function is the secant function. And the value inside the grouping symbol that's being added or subtracted is our horizontal shift. So what does the minus pi over 2 make our graph do? Right. Pi over 2 units. And what's the plus 2 at the back make it do? Up 2 units. If you have multiple transformations, the first thing you need to do is move your graph left or right. So do that first. So if you're dealing with the secant function, what's the reciprocal for secant? Cosine. So I'm going to draw the cosine function, now I can then find the secant function. So the cosine parent function starts at 1, it ends at 1, halfway is at negative 1, a fourth of the way is on the x-axis, 3/4 of the way is also on the x-axis. I'm going to just dot this in because is this the graph I want? Do I want the cosine graph? No, what do I want? Secant. Okay, so now, let me fill in some x values. Here's 0. What is the entire period for cosine? 2 pi. So right here, it's 2 pi. This would be halfway, which would be what? Pi. And this would be half of pi, which would be pi over 2. So if this one is pi over 2, what is this one right here? Negative pi over 2. And this is pi over 2, 2 pi over 2, this would be 3 pi over 2. And once you have the cosine function, you can get the secant function. Wherever it hits the x-axis, that's where you will have a vertical asymptote. So we'll have vertical asymptotes at negative pi over 2, positive pi over 2, and 3 pi over 2. So everywhere the cosine function touches the x-axis, we'll have vertical asymptotes. Now for our parabolas. Remember we have the alternating parabolas, one concave up, one concave down. So when I draw those in, let me do black. We share the point, but if this one is concave down, the secant would be concave up. And if this one is concave up for the secant, it would be concave down. Now, when you're doing your graph, really, you just have to concentrate on one parabola. Because if you know this one is up, then you know the next one is going to be down. And if this one is down, the next one would be up. So I'm just going to concentrate on this part of the graph right here for my transformation. So if you have multiple transformations, the first thing you need to do is move it left or right. So the first thing we need to do is move these vertical asymptotes. So if I have a vertical asymptote at negative pi over 2, if I move it to the right pi over 2, so it should be right here for the parent function. But if I move that to the right pi over 2 units, where would it be?
0.
At 0. So that first vertical asymptote has been moved to 0. That second vertical asymptote normally would be at positive pi over 2. So here's pi over 2. If I move this asymptote to the right pi over 2 units, where would it end up?
Pi.
At pi. So that was the first transformation. We moved it left to right, and we did that by moving the asymptote. Second transformation, what does the plus 2 at the back make it do?
Go
Go up 2 units. So for this parabola, what is the y value right here?
in the middle.
What is the y value on this graph? 1. So normally, this point would be at 1. But what do I have to do with it? Move it up 2 units. So instead of it being at 1, I need to move it up to 3. And this is the parabola that is concave up. So that one is concave up. The one that's over here would be concave down. Where would the next vertical asymptote be? This was at pi, the next one would be at 2 pi. Now, we just did the parabola that's concave up. If I look at the one that's concave down, what's the y value right here? Negative 1. So normally it would fall right here at negative 1. But if I move it up 2 units, where would it be? At positive 1. And if that first parabola is concave up, the next one would be concave down. Okay, now just repeat that. Draw a vertical asymptote at negative pi and negative 2 pi. And we left off at concave up. So the next one would be concave down. And the next one would be concave up. So what was the phase shift?
Negative 2 pi. Plus 2 pi.
How would I say that in words?
Translated 2 pi.
Translated which direction?
2, right?
Translate right, how much?
Pi over 2.
Pi over 2. Translate right, pi over 2 units. Now for the vertical shift, what would you say for the vertical shift?
Plus 2.
Instead of plus 2, how would you say that in words? Up 2 units. And what's the period for secant?
Pi over 2. Pi.
How long does it take to make a parabola that's concave up and one that's also concave down? We need both of these together, and this distance is 2 pi. So the period would be 2 pi. Okay, last one, number 6. We have y equals cosecant. Inside the grouping symbol, we have x plus pi over 2. So the plus or minus inside the grouping symbol moves it left or right. So if it's a plus pi over 2, which way does it move the graph? Left pi over 2 units. And what does the minus 2 at the back make it do? Down 2 units. So if you have more than one transformation, move it left to right first. So let me sketch what it would look like over here. Out to the side. And what's the reciprocal for cosecant? Sine. So I'm going to first draw in the sine function. So sine starts at 0, ends at 0, halfway it's at 0, a fourth of the way it's at 1, 3/4 of the way it's at negative 1. Just going to dash it in. And wherever that function touches the x-axis, we will have a vertical asymptote. So we have a vertical asymptote at 0, at pi, and also at 2 pi. So those are the three vertical asymptotes, 0, pi, and 2 pi. Now I need to make my parabola. So here's my shared point. If this is concave down, mine needs to be concave up. Here's my shared point. If this one is concave up, this parabola needs to be concave down. Now when you're doing your transformations, don't worry about both of them, because once you know one is up, what's the next one going to be? Down. So I'm just going to look or focus my attention to this parabola right here. I'm just going to look at the one that points up. That's the one I'm moving. So the first thing, if you have more than one transformation, move the asymptote first. So instead of being at 0, I need to move this left pi over 2 units. So if I move it left pi over 2 units, where would that asymptote be? Negative pi over 2 is right. And the second asymptote is normally at pi. If I move that one to the left, pi over 2 units, where would it be? Positive pi over 2. So there's half the battle, knowing where your parabola needs to be between. So those are my asymptotes blocked off. Now, this value, what's the y value right here? 1. So normally this point would be right here at 1. But now I need to do my second transformation. And what does the minus 2 make it do? Down 2. So that point needs to be moved down 2 units. So instead of being at positive 1, and move down to negative 1. Now when I draw in the parabola for that point, does it need to point up or down? Look right here. I moved the one that's concave up, so this parabola needs to point upward. Now I need to complete the cycle. And where would the next vertical asymptote be? 3 pi over 2? Where would the other one be? Negative 3 pi over 2. Now for the parabola that's concave down, what is the y value normally right here? Negative 1. So normally this would be right here at negative 1. But what does the minus 2 make it do? Down 2 units. So if I start at negative 1, when I move it down 2 units, it's going to be at negative 3. And if that first parabola points up, the next one needs to point down. And the next one, I don't have enough room to do the entire thing, but that next one would point up. So we have up, down, up. This next one over here would be down. And the next one would be up. So make sure you do your partial cycles. If you can't do a full one, make sure you do the partial ones to fill up the entire graph from negative 2 pi to positive 2 pi.